The measurements are within tolerance.
Excellent.
Proceed with the batch.
Understood.
Notice the significant radial cracking here, indicative of low thermal shock resistance.
Yes, completely failed, whereas the new batch holds solid.
The stress test resulted in significant deformation. This one held up.
Log the fracture parameters and initiate a rerun at lower strain.
Essa velocidade não é de meia duração do mapa, é importante, muito longe, lançar nesse governo, mas está nesse raio.
Measure is 3.01. Specifications call for 3.0. Perfect.
The geometry here, specifically the angle of the siphon, is incorrect. It will not generate sufficient suction.
Show me exactly where.
You can see how the internal core sections interlock perfectly to form the hydraulic channels. This fit ensures precise flow.
%, ready for glazing.
The glaze curve is slightly off. I need to adjust the formulation data to match the body.
Okay, make the adjustment and let's check the new projection.
No, kamu nang jum fize din das ngana kan din. Sendiri dari.
Phase. The silica fuses with the alumina from the kaolin to form new crystalline structures called mullite, needle-like crystals that interlock and create a three-dimensional lattice of extraordinary strength. The individual particles of kaolin, feldspar, and silica that were simply pressed together in the green stage are now chemically bonded into a single, unified material. This is called vitrification. The ceramic has become, in a very real sense, partially glassy. The distinction between the mineral particles has dissolved. There are no longer three ingredients. There is now one material, and simultaneously, on the surface, the glaze minerals have completely melted and flowed into a continuous, bubble-free, perfectly smooth layer of glass. The colors are extraordinary inside a firing kiln. The pieces glow with a deep, orange-red luminescence. The heat distorts the air above them in visible waves. The ceramic light they emit is the same phenomenon that made ancient potters believe that fire was a living, transforming force. They were not wrong. As the pieces travel through the cooling zone at the end of the tunnel kiln, the temperature drops slowly and precisely. Too fast, and the glass phase would freeze with internal stresses that would cause immediate or delayed cracking. The cooling curve is engineered with the same precision as the firing curve. When the pieces finally emerge from the end of the tunnel, they are cool enough to handle, transformed from fragile earth into dense, vitrified ceramic, and they have shrunk again. Another 8 to 10%. Combined with the drying shrinkage, the finished piece is approximately 15 to 20% smaller than the original mold. The mold was designed for this. Everything was designed for this. But the kiln is not the end. Before a single toilet leaves the factory, it must prove itself. The quality control process in a modern sanitary ceramics facility is systematic, methodical, and surprisingly rigorous. Every piece is inspected visually under controlled lighting conditions that reveal surface defects invisible in ordinary light. Gauges verify that mounting holes and bolt patterns are within the specified tolerances. Acoustic testing, tapping the piece and listening to the resonance, can reveal internal cracks that have not yet propagated to the surface. And then comes the flush test. The hydraulic performance of a toilet is not a simple thing to measure. It is not enough for water to flow through the bowl. The flush must create the precise hydraulic conditions needed to clear the bowl completely in a single cycle, to initiate and sustain the siphonic action that empties the trap, and to refill and reseal the trap before the cycle ends. Engineers use standardized test media, solid materials of specific density and size, to evaluate whether the flush hydraulics perform within specification. The water flow, the fill time, the vacuum created by the siphon, the seal depth of the water in the trap. All of these are measured, recorded, and compared against design parameters. A toilet that fails any one of these tests does not go to market. It is recycled or destroyed. The percentage of pieces that fail in modern facilities with precise process controls is remarkably low. But it is never zero, because ceramic is a natural material with natural variability, and the manufacturing process, for all its engineering precision, is ultimately a collaboration between human design and the physics of earth and fire. Sometimes the earth wins. So the next time you walk into your bathroom and you encounter this object, this white, silent, absolutely unremarkable piece of your daily life, try to see what is actually there. A mineral formula developed over decades and refined to a precision of fractions of a percentage point. A liquid earth that was coaxed into shape by the capillary action of plaster. An invisible internal geometry, calculated by hydraulic engineers, that manages fluid dynamics every time you press a handle. A surface of glass, molecularly fused to a lattice of interlocked crystals, that keeps your bathroom hygienic with nothing more than water and soap. An object that has been through fire hotter than the surface of certain stars, and come out the other side stronger, denser, more unified than anything it started as. It survived temperatures that would destroy almost every other material in your home. It survived the pressure of the mold, the fragility of the green stage, the violence of the kiln. Survived to serve you, quietly, reliably, without asking for a single moment of your attention or your appreciation. And now you know what it is made of. You know what it endured. You know the invisible curve inside it that makes everything work, and the glass surface that keeps everything clean, and the crystalline lattice that makes it strong enough to last a lifetime. You know the whole story now. So the question is, the next time you walk past it without looking, will you still not look? If this changed the way you see something you thought you already understood, leave a comment below. And if you want to keep going deeper into the hidden engineering of everyday objects, you know where to find us.